Welcome to NetLabs Hub. Today we are going to configure Dynamic NAT. Have you ever configured NAT in Cisco Packet Tracer and just nothing works? Where computers can't reach the internet, servers do not open, the NAT table stays empty. So focus on this video. Today I'm going to guide you step by step configuring Dynamic NAT and troubleshooting all those issues leading to such particular problems. So this is the topology that I have cabled. As you can see, I have two routers. There is the ISP router here. This is the edge organization router, and this is the LAN. So let's use this part, Dynamic NAT. Dynamic NAT, that NAT is the network address translation. This is the mapping of many private IP addresses to many public IP addresses, whereby, as you can see definition, I have defined it here, and these are the characteristics. So when you compare Dynamic NAT to static NAT, this one seems to save IP addresses compared to that. So there is no guarantee of using the same public IP, like internal computers or internal users are randomly mapped to each public IP. So there is no guarantee that a computer will repeat using the same IP next time it will be mapped. And this is the principle that you have to note. Outside cannot initiate connection. I mean, if you are not on that particular mapping pattern, you cannot initiate communication. So for example, public pool, we just create a public pool. Like for example here, this is a range of the first 10 IP addresses that shall be mapped to the first 10 IP addresses in the private LAN. So let's embark to our configuration, to our topology, sorry. So these are the steps that I'm going to follow as I configure this lab. I finish configuring, then I start troubleshooting so that we can know which are these errors or problems that real engineers face in the network environment while implementing this kind of service. So the first step is that cable and assign IP addresses. As you can see, I have done the first step. Let me assign IP addresses. On this interface, let me start with the router facing the LAN. Put no. Enable to move to privilege mode. Config terminal. We set the host name. This is edge router 1. After host name, we set the banner. Then we move to interface, gigabit 0/0, then IP address. As we can see, it is operating on 192.168.10.0. So the first IP address is 1. So this is it. No shutdown. We describe this interface, main interface. So this interface I have configured the IP address. Let me go to interface 0/1 and the address is 41.10.12.1. Exit interface 0/1. We save our configuration, copy, running, startup. I'm saving my configuration file to the startup configuration file so that upon restarting the router it won't be lost. Or we can do write memory. Instead it will save. Go to this router, my ISP router, socket 0/0. I assign it .2. No. Enable to move to privilege mode. Config terminal to global configuration mode. Hostname ISP underscore router 2 banner. So interface, when you want to save and you are not in the privilege mode, you just use this command do, then copy, run, start. That is the short form for copying running configuration file to startup file. So that is it. For this now, even though this is the small network, I don't want these computers to assign them IP addresses statically, because it's a bit tedious, and to save on time I'm going to configure this router to serve as DHCP server to these 4 computers. So this is the step configuration. So IP DHCP pool. The steps, we start by creating the pool, defining the default gateway for the default gateway that the internal computer shall use to access the server. Then we specify the network. Then the last option, we exclude the IP addresses that we don't want them to be used on the pool. So IP DHCP pool, then let's say that it's LAN. Then default is the first IP address in that subnet, that is 10, but we do not assign the net masker. Then we specify the network 192.168.10. After there, we can give DNS, no problem. Let's give 41.10.12.2, the IP address of the ISP. From there we exclude, then we exclude a certain range of IP address. So we exclude 1 because it's assigned there up to 90. So my 4 computers will start getting the IP address from 91. So that is it. Then we enable this router to serve as the DHCP server using this command service DHCP. That is it. We end, then save. So let me enable my computers to be DHCP client. It's successful. It has gotten from 91. So this should be 92. As you can see, I tried configuring it and started at 100, but now I have reverted it to 91, so that is 93. Then this one is 94. This is how to enable them to be DHCP client. So as you can see, it has gotten the DNS is this one will serve as our DNS. Then the gateway is this interface. So this can ping this. You can give it a try. Ping 192. You see, it's pinging. .95 can .94 can ping 91, can ping 92. That is it. So the next step, I'm going to enable NAT. This is the core topic or the core section for this project. So I will start with this interface. This interface, it is the inside interface because it is facing the LAN, internal network. This one, gig 0/1, it is the outside interface facing the ISP. So I'm going to enable NAT dynamically, in that when this computer tries to communicate with the internet, this internal IP is going to be translated or temporarily mapped to external public IP that exists in the pool that I'm going to create on this router in line on this interface. So this is the step. Let me start with the interface facing LAN. Interface gig 0/0. After there, then we say IP NAT. Then as you can see, we've got inside interface for the address translation, outside interface for address translation. So inside is the interface facing the LAN, then outside is the interface facing outside the LAN. It might be the internet or external network. So this is inside. Then from there, we've enabled LAN on that interface. We've enabled NAT on that interface. Then we go to interface gig 0/1. Then we say IP NAT outside. So this I have enabled on this interface NAT inside, then on this NAT outside. From there, I'm going to create the pool for the public IP addresses that these internal addresses shall be mapped to. So these are the steps to create the pool. We exit to global configuration, then IP NAT pool, then we give the name of the pool dynamic_NAT. That is the name of the pool, and you should always remember that name of the pool, because when it comes to binding the pool to the access control list that you've created, the name should match. So after giving the pool name, then we give the range of public IP addresses that will be used in mapping the internal 12.1 to 41.1 space 41.10.12. Can give it up to, because this is 1 to up to 4. Let's just say 4, because we just need 4 IP addresses. So or 5. That is it. That so after giving this, we say net mask. That is the subnet mask to define the network. So that is it. I have finished creating the pool. After creating the pool, we go to step 4, ACL. Now we create the access list to permit the internal network to access the external network. This is the steps. We just create a standard ACL, that is access control list. So we say ACL list. So we specify, you see, we've got types of ACL. We've got standard and extended. Standard ranges from 1 to 99, then extended starts from 100 to 91, 100 to 199. So we say we give the ACL number, specifying which type of ACL that we're gonna use. Then we use the word permit, allowing the internal IP, the internal network to access the external. So permit, then we specify our internal network, which is 192.168.10.0. Then we give the wildcard mask. The wildcard mask, to calculate the wildcard mask, we take 255.255.255.255, the complete octet. Then we subtract our subnet mask for this network from that. So once we do that, we get 0.0.255. When 255 is subtracted from 255, that is 0. That's why we are getting 0. So it is that way. You can you will check on the lab that I will do next on the OSPF on how we calculate the wildcard mask. So that is it. I have created the pool, then created the ACL. Now the last thing is to create, second last thing is to bind the ACL to the pool. So let's bind the ACL to the pool. IP, we start with the IP NAT. Inside we specify on which interface we want to bind. IP NAT inside source list. So source, then we specify the access list. You see, we can specify 1 because we use the standard ACL. Then pool, then we remember the name of the pool. That's why I told you that you have to memorize the name of the pool here. We can just copy this way, then paste it here to be sure. So that is it. We've now bound the ACL to the pool. That indeed the IP address allowed to access the outside shall be verified through the ACL that I have just created. So after there, now we specify the default route that all internal computers shall use to access the internet. To specify the default route, we use IP route, then the whole network. It means the whole network, then the whole IP segment, then the whole net mask. So we specify that one, that is for the IP address segment, then that is for the network. Then after there, we give it the IP address of this router, so that I'm creating that every computer in this network with the subnet mask specified is able to access this. So we should be able to ping to this compute to that ISP router. So we give 41.10.12.2. That's the IP address of the. So I'm done configuring dynamic NAT. The steps are: you first cable your network, assign IP addresses. 2, you enable NAT on the interfaces, on the inside and outside interface. After that, you create the pool of public IP address. Then you create the ACL, standard ACL, that shall be verifying the internal IP as it is mapped to external. So from there we bound the ACL to the pool that is created on the router. Then we finally define the default route. So on the part of configuration, I'm done. So let me just verify my work, that it works. So let me start by, and remember, this is the concept that the mapping is just temporal. And this is how it works. Dynamic NAT, dynamic network address translation, works in these steps. These are the steps that it works through. So for example, this computer, let me give it admin just in case. When this computer sends traffic to the internet, to this router, it will first send it to the switch. The switch takes it to the router. This router checks the access control list that was created, if it is for the permit or deny. If it is permit, it will then allow the traffic to move further. So after there, the router picks the public IP address from the pool. We've created the pool on this. After verifying the access control is right, then it moves by picking an IP address from the pool specified. Then the router creates a temporal translation. So it creates a temporal mapping. Once the traffic moves, then that particular temporal mapping is distorted or removed. So mapping is only created when traffic flows, and when it stops, the mapping temporarily stops. And that is it. That's how dynamic NAT works. I will show you what I mean by when traffic flows, the mapping or the translation is done, but when there is no traffic that is flowing, there is no translation. So for example, when I ping, let me first confirm something. To confirm the if NAT is working, we use show IP NAT, either translation or statistics. So these are two commands that are used: show IP NAT translation or this. So first of all, let me check if at all there is traffic that is flowing. Show IP NAT. You can see there is statistics or translation. So let me start with the statistics. You can see the statistics. Total translation 0. Outside interface is gigabit 0/1. This is the interface this is the outside interface. Then gig 0/0. This is it. That is the inside interface. Hits 4, misses 27, expired translation 4, dynamic mappings. You see? So it means we've successfully configured this project with dynamic NAT. So let me show IP NAT translation. You can see if there is no traffic flowing, the command will just take into effect, but it will show nothing. But if there will be traffic, then you will see here the mapping. If this particular admin PC has sent traffic, then it will take its IP. Then that IP will be mapped to a different IP from the public pool. So let me send traffic to this and then try. Forget about these pings that you are seeing. This is the start when I was verifying the DHCP server. So ping 4110.12.1. This is the gateway facing the ISP router. You see it is pinging. Okay, it's pinging. Let me ping the ISP router now. It should ping. You see, it is successful. So now after sending the traffic, now we can now verify the statistics and translation. Let me start with the statistics. Show IP NAT statistics. You see statistics, it has changed. Here it used to be 0 and 0, but you see there is 4 dynamic, 4 extended. Something has been done here. Hit 7, the initial hit was, we can check it here, the initial hit was 4, then misses 27, then this aspect was 0, and this and 0 static, 0 dynamic, 0 extended. But after initiating traffic, let's now check 0 static, 4 dynamic, 4 extended, then total translation is 4. As you can see, 7 hits, then misses 27. 27, it means that out of 27 plus 4, we get that one. That is it, expired translation 4. So this is it. As you can see, dynamic NAT. So this one, 12.1, and 12 this one. So that is it. Show IP NAT translation. The traffic has expired. So let me just check. Send again. So I have initiated the, as you can see, after sending the traffic, now you can see the mapping. 91 is the admin PC. You can see these are the mappings. This is the, we've got inside global, inside local, outside local, then outside global. Outside global is this one, the IP address for the ISP. Then inside local is the private network. Then outside local is this IP, is the gateway for the gateway facing the ISP. So that is it, how we can configure dynamic NAT. So let's move to the aspect of troubleshooting. To troubleshoot this, first we will just reverse this. You find that by removing, let me remove, for example, you finished configuring, but the internal PC cannot access the internet. First check if all interfaces are up and running. If all interfaces are up and running, for example, I can do this. This is gig 0/2. Then let me shut it down. Enable config interface gig 0/2. Shut down. The moment I shut down, even there is no need of saving, then try to initiate traffic from here. Ping 4110.12.1. It's not going to ping. Sometimes you may finish configuring, but you've missed or you've forgotten to bring up the interfaces. It won't help to traverse the traffic to the internet. Now you can see all the packets with the request timeout until the statistic shows that sent for received nothing, and then loss is 100%. So This is one of the things that you should check. Shortcut for bringing up the interface is this one. Upon bringing up this interface, now we can ping. You can see the interface is up, we can ping. So that is one way of troubleshooting that. Two, check if the access control list is well configured. As we said, access control list, let me show running config, show running config. As you can see, this is the pool for DHCP, that is an issue for this project. As you can see here, if you mismatch of the interfaces, if you configured the outside interface to be the inside interface and the inside interface to be the outside interface, NAT will not work. You should begin where to configure either inside or outside. Be sure of what you are doing, and also ensure that there is no communication that will happen if there is no IP address well assigned. By meaning well assigned, I mean the IP address should be in line with the desired subnet mask. For example, this is private class C IP addresses. We are supposed to have, this is the default subnet mask. When we have 255.255.0.0 with this IP, there will be no communication because 255.255.0.0, that is the default subnet mask for class B private 172.16.0.0/16. So those are the things that you should check. Check the interfaces, the status of the interface, check whether the ACL is well configured, check if the IP addresses are well assigned with their respective subnet mask. Also, this is the aspect that I'm saying. As you can see, access list 1 permit this, the whole of that network. So if this is wrongly configured or not configured, the internal IP private addresses will have it rough accessing the internet. That is one bottleneck. Two, the failure in configuring the default route. If you don't configure the default route, that if at all traffic from the internal network lacks a specified route, there will be no way to direct this traffic to the desired destination. So this should be configured, and this is how to do it. Second thing, the misconfiguration of the public IP IP address pool. If you do not configure the pool, the internal IP addresses will fail in mapping or in translating because the designated pool is not well configured. Like here, I hooked the first 4 IP addresses to be internally mapped to the internal computers, that is. So these are the issues that you should consider while troubleshooting NAT, specifically dynamic NAT. Check the access control list, check the default route, check the public pool of IP addresses configured, and also ensure that the status of the interface is up. Then IP addresses are always configured well. That's when it will work, or else it won't work. So mostly sometimes you find an engineer has toiled on the project configuring it day night, and then at the end of the day servers cannot be opened. This computer cannot access maybe the website. The website cannot be accessed. You may find that there is no pool that has been created, or the path, or the route has not been specified, or the access control for this has been misconfigured, in that in the case of allowing it or permitting, it has been given a deny, so it is blocking. So those are the issues. Okay, so I finish by checking the status of this translation from this aspect from the last computer, that is. I just use the up arrow to turn back to the so for 110.12.2, that is it, it's working. So that is it. Thank you for taking your time to follow this. If you feel this video has helped you so much in understanding dynamic network address translation, feel free to subscribe, feel free to comment, like and share, and in any case of maybe not gotten what you've you've seen, or maybe you feel some further explanation, you can just comment, then I'll just contact you or get to let you know more about it. Thank you so much. Keep fixed and focusing on NetLabs Hub channel for more. Thank you. The next video shall be on static NAT that I will do even the same, and we share. Thank you so much.